In this video, we're going to be tackling the LeetCode question, linked list cycle. A cycle in the world of software development is actually pretty common. Let's just say that you are an API developer and one day you are deep in that backend. You are looking at your Swagger console and you see a crazy response come back. A possible object cycle was detected. This is a cycle. But what exactly is going on here? What's going on is that you have an object referencing itself in a very similar pattern to an infinite loop. Let's just say I incorrectly modify the API. I incorrectly modify the model so that the same exact object is calling itself. What happens is you have an object that's referencing the same exact object. And once this happens, you create a cycle because the same exact object is calling the same exact object and it crashes your program. This is very similar to what happens in linked lists. Because linked lists, at the end of the day, you guessed it, are objects. And in our example here, the very last node, the very last object is referencing a node, an object within the middle of the linked list. This is what's going to create the cycle because inevitably you're going to have to traverse it and it's just going to get stuck and it's going to be a big problem. This is why we have algorithms to combat these situations. By far, the best way to find a cycle in a linked list is going to be Floyd's cycle finding algorithm. Not only is this algorithm fast, but it's pretty neat and intuitive in how it works. Let's just say that I have a circular track. This circular track is meant to represent a linked list with a cycle. It goes around in a circle. It goes round and round. And let's just say that I release a very fast rabbit and a very slow turtle. What's going to happen is that eventually this rabbit is going to be so fast that it's going to lap the turtle. And by lapping the turtle, this is how we identify a cycle. Let me explain a little bit further with another example. Let's just say that we have a track, we have a linked list that does not have a cycle in it. It's just a straight linked list, exactly the way that it's supposed to be. In this example, what we have is we just have a track that goes straight and it does not have a loop. What's going to happen is when we release the fast bunny rabbit and the slow turtle, the fast bunny rabbit is just going to run to the very end and the turtle's never going to be able to catch up with it. And that's how we identify if a linked list does not have a cycle. So let's go ahead and let's visualize this algorithm step by step. An important thing to remember about this algorithm is that it's just a two-pointer. It's a fancy two-pointer. It's the two-pointer version of a linked list. With that being said, let's just go ahead and initialize our pointers. The very first pointer that we're going to initialize is going to be our turtle. We're going to initialize our slow pointer at the very first element. This is going to be our turtle. Next thing that we're going to do is we're going to initialize our second pointer. We're going to initialize our rabbit. How exactly is that going to work? We're going to initialize our rabbit at the second element. Another important thing to realize is that not only are we going to initialize these two pointers, but we're going to make one pointer fast and we're going to make one pointer slow. But how exactly does that work? How do we make a pointer slow or fast? What's going to happen is that the fast pointer, the pointer with the rabbit on it, is going to move up 2 places each iteration. And what's going to happen when the slow pointer, the turtle pointer iterates is it's just going to move up 1. This is going to ensure that the rabbit is going to reach the end first if we don't have a cycle. But let's talk about if we do have a cycle. Here we have an example where we do have a cycle within our linked list. And as usual, our rabbit is going to zoom out into the front while our turtle lags behind. Our rabbit is going to circle back. But when our turtle and rabbit meet, we're going to break out of our logic because that means we do have a cycle. The rabbit and the turtle should never meet. But if they do meet, that indicates a cycle. And that's how the algorithm works. But let's go ahead and let's turn this into code. So we are inside of IntelliJ, and the first thing that I'm going to do is create the node. I think creating the node, although you don't have to, is great practice and it's a great learning experience. And also AI does most of it now. So we're going to have an integer of val. We're going to have a list node, so pretty much a self-referencing node. And we're also going to have a constructor that's going to take in our val. So we'll set val to x, and then we'll set the next equal to null. Congratulations, we have just created our node. So now what we're going to do is we're going to create a new Java class, and I'm going to call this solution. Within the solution class, we're going to house our method. And this method is going to return a Boolean because we need to just return true or false, whether it has a cycle or not. I'm also going to name this has cycle, and it's going to take in the head, which is going to be a list node. Let's go ahead and just handle our edge cases. And we need to check if the head is equal to null. And if the head is equal to null, we're going to go ahead and return false because there is no cycle, obviously. Now that we have our edge cases built, let's go ahead and declare our 2 pointers, our turtle and our rabbit. First, we're going to declare the turtle. It's going to be the slow pointer, and we're going to initialize the turtle at the very first element. Then what we're going to do is we're going to declare our rabbit, our fast pointer. And our rabbit, our fast pointer, is going to start at the second element. But you could totally have them start at the same element if you want to, but I'm going to have the rabbit start at the second. Next thing that we're going to do is we're going to begin iteration. What we're going to do is we're going to iterate, and we're going to keep iterating until one thing happens. When the rabbit and the turtle meet, when they collide, that means we've detected a cycle, and we're going to keep iterating till we detect a cycle, and when we detect the cycle, we're going to break out. But while we are iterating, we also need to do something else. We need to check if the rabbit has reached the end. And the way that we do that is we just check if the fast pointer, the rabbit pointer, has reached null, if it equals null. And if it equals null, that means we've reached the end. We don't have a cycle, so we're going to return false. But if we're continuing to iterate, we have to move the rabbit and the turtle pointer forward. How exactly do we do that, though? We have to do this manually within linked list. And the way that you do that is you reassign the slow to the slow.next, which moves the pointer forward. But we also need to do this for the rabbit. And we also need to do it faster. So what we do is we assign fast.next.next, and this skips a node. And we also need to handle when the slow and the fast meet. And if the slow and the fast meet, we're going to break out of the while loop and we're going to return true. And that's pretty much it. So let's go ahead. Let's copy this, going to get out of full screen mode, and let's toss this into LeetCode to see what we get. So I've got my LeetCode editor right here. I'm going to go ahead, toss the code in. Let's run our test, see what we get. Tests are accepted. Let's hit our submit, see our time complexity. Time complexity is, let's see, n, and also our memory is constant. Congratulations. We have passed the interview. Hope that you guys enjoyed this. If you did, smash that like button, smash that subscribe button. As always, thank you for watching.